Hi everyone, I'm DJ Cole, a technical marketing engineer here at Cisco. Today I'm going to be talking about our new IW9167E access point. It's industrial wireless access point. But also not only the access point, but also how we're simplifying deploying mobility in industrial settings, right? Which is kind of a new thing coming up with AGVs, all sorts of applications that are mobile and that can't be wired. So as I mentioned, what I really want to get to, though, is a feature called MPO. But before I can really talk about MPO and multipath operation, I kind of have to introduce you to this access point. That's the name of the access point. Full name, Cisco Catalyst IW9167E heavy-duty access point. So what is this access point? So as you may have already seen here at Cisco Live in the previous presentations or on the showcase floor, we just released our new line of access points, the Catalyst 9160 access points. This is kind of the top line of that series. This is a outdoor access point with three radios. So a 2.4 gigahertz radio, a 5 gigahertz radio, and a third radio that either does 5 gigahertz or 6 gigahertz. 6 gigahertz is still kind of pending government approval, and depending on which country you're in, it may not even be considered for government approval this time. But you can use that third radio for 5 gigahertz up until that point. This is sort of the twin of the CW9166 access point. That's the same architecture as this access point, but in an indoor case and with internal antennas. This access point, you'll see it does have, some of you got the chance to pick it up. This access point has 9 antenna connections. 8 of those are for data radios, and this middle one on top is actually for a GNSS receiver that's built into this access point. Because of those external antennas, and 6 gigahertz, this will be a standard power access point in the in the US per FCC regulation once those regulations are finalized. So it will require AFC, and that's what that GNSS receiver is for, in addition to a barometer that's built into this device. To support those 3 radios, we do have the multi-gigabit RJ45 and SFP. It's kind of behind this port here. I can't really show it to you, but inside here there's a RJ45 port and a SFP port. And actually, all 3 of these, so that this is the power and these are the 2 data ports, those are adaptable to M12. So rather than having M12 built in and forcing our customers to use M12, it's optional, but you can buy that accessory and then plug an M12, which is an industrial end cable into the access point directly. So heavy-duty design, right? Like, what does that mean? So comparison to an outdoor AP, how is this different, right? The big difference is the certifications. So before I worked at Cisco, I worked for a theme park for 6 years and doing industrial wireless on roller coasters, dark rides, things like that. During my time there, we actually installed some access points on the front of roller coasters. So we put 1242 access points on some of our dark rides and 3502 access points on the front of roller coasters. And as you can imagine, there were a few failures, but for the most part, they actually worked, right? We didn't see a lot of failures from vibration or anything, but it's nice having an access point that you can take to those environments and know that it's going to be certified and that you can put in there without any worries of vibration or anything like that being an issue. So now that industrial wireless is an option, both this and its predecessor, the 3702, just easier to use an access point like this in those environments where you know that you're going to be subject to vibration. And I mentioned M12 connectors. The previous generation had M12 connectors. This one does as an option, so you can use that and then switch over that older generation AP to this generation AP. So what are really the deployments for our industrial wireless access points? So under the umbrella of industrial wireless, we have both Wi-Fi. So that's like tablets, things in factories, what you would expect with your typical wireless deployment. But we also have mission critical systems. And some of those examples are kind of on the right? The one I talked about is entertainment. In an entertainment system, you don't have users, right? You don't have users that are using tablets. You're basically using a process and automated equipment. And in those type of situations, you're dealt with more strict safety requirements. So you have systems, sorry, let's set this down. It is a little bit heavy. You have situations where you have hundreds of sensors that are all like looking for a reason to fail, right? And when you extend those systems over wireless, you have to make sure that the latency is to a point where those systems aren't going to like trigger because of that wireless network. And it's not like these deployments didn't use wireless for many years, right? In the themed entertainment industry, we used wireless even before 802.11 had letters after it, and before before we had products like this. But now they're becoming more critical and more integrated into those attractions. So we have the need for lower latency than we had before. We have the need for higher bandwidth. But most often when we see mobility, we have the need for zero loss handoffs. And sort of this is the list I come up with why do industrial wireless engineers, when you get to that level of kind of expertise where, we have a lot of people out there today that have experience deploying Wi-Fi, but what extra experience does it take to deploy industrial wireless into an environment? And these are sort of the top 10 reasons why industrial wireless engineers, people like me that had to go out there and actually deploy this in things like theme park rides, mining, oil and gas, AGVs, what do you lose sleep over? And I'll share a little bit about why, what we're doing to try to help that when you're dealing with mobility. Number one, as I think all of you can probably respect, spectrum is very limited today. So spectrum, we only have so much of it that we can use for mobility. This product unlocks 6 gigahertz, but today 6 gigahertz is not something that we can really see using for mobility because for the most part, mobility is not allowed with 6 gigahertz. We have the design of those networks and how well you can adhere to the best practices of doing wireless. Something like a theme park, we had a lot of restrictions on, what could you really do in with all like the IP and design of those attractions, and where could you put APs, right? A lot of people, when you're dealing with something like healthcare or retail, you can pretty much put the access point wherever you want. But when you're dealing with an industrial environment, you're going to say, I want to put an AP here, and just about everyone, all the designers, mechanical engineers, structural engineers, facility, are going to come to you and say, well, you can't put it there, and give you a reason why you can't do that, right? So you're never really able to put the AP exactly where you want it. And it's also the communication stack of whatever system that you're dealing with. So you have like AGVs, right? And you have a communication platform for those AGVs, and they communicate together, right? A lot of those systems were designed for wired networks, and you can't really just take that system that was designed for a wired network and put it on a wireless network and expect it to work right. Sometimes the latency, it's sort of like if you take SMB2 and you put it on a WAN connection, it's not going to perform very well. It's the same thing with a lot of these industrial systems. You put it on a wireless system and they sort of break down with the extra latency. And it's also the time that you get for commissioning. So a lot of these projects, you go out there with the best of intentions and a project schedule, but delays happen, and now you're kind of stuck. And the network is always the least important thing when you're deploying a wireless network, and you don't get enough time to fully tune and deploy your wireless network. So this is sort of what we have today when we talk about, I'm going to introduce a feature called multipath operation, or MPO. This is sort of what we have today, single path operation, right? You have an AGV on this side, you have a controller on that side, a PLC that's kind of controlling the AGV from the wayside. And typically you're going to have more than one AGV. And this is very simple, right? This is just a point-to-point connection. In a factory, you're going to have more AGVs, but this is kind of just to demonstrate, right? You send your packets, they go across the wired. They're a little bit more spread out because you have that latency, and you have the shared medium of the wireless, and then they get to the other side. Today, if you have interference, packet B, it was only sent once. Maybe it's probably going to be retransmitted a few times in actuality, but something happens and it doesn't get sent. That packet goes away. So what is our answer for that with our industrial access point at Cisco? We are coming out with a feature called MPO, where we're essentially, as you can guess by the name, we're using multiple paths to send that same packet, so that it can be received on the other side reliably in order. So what does that look like, right? We have the AGV now, and now we're sending that packet 2 different ways. So now if you have interference on one, that packet still went through the network to the gateway on the other side. Here's kind of that same diagram, right? So now you have your AGV, you have those 3 packets, and you have those packets across 2 different links. So in this example, right, you still only have 2 of those access points. And again, this is a very simple diagram. I'll show you a bit more complexity in a second. But we're taking those packets and we're sending them across 2 different links, right? So you have your ABC packet, and we're appending a trailer on them to get them to the other side, duplicate them, and send them across the wire. So now, if you have interference on one of those, B still got across the network, right? You didn't drop B on the network. This is kind of the more complex version of that, as you can expect in a factory. So here you have that same AGV, but now we've deployed a number of these access points across the factory floor. Same concept here, but this is with our Cisco ultra-reliable wireless backhaul technology. We're able to send these packets to different base stations, and they're able to hand off as that access point moves across the floor. Now it's rather than being on the same radio on two different frequencies, now they're across different access points, either on the same frequency or on different frequencies. So same concept. As you move, those connections moved with you, and now they're being rerouted across our curb network, across the factory, across the wired infrastructure and wireless.
So when you go through and kind of build something out like that, kind of using this diagram, you've got the AP on the bottom and you've got the kind of the two in the middle row. Are those kind of statically pinned? Is this, when the AP comes online, it just picks two that are adjacent? Is it done per flow? Is it done per packet? How does it figure out what route to take?
Sure. So with our curb technology, it's actually looking at the signal strength. So the primary path, which is actually going to be the path with the ones on it, that would be if you're not using the MPO feature and you're just sending traffic kind of without MPO, non-protected, it's going to pick the one with the highest RSSI. But this access point in this mode is actually it's listening to all of these and then picking which one's best. And it actually uses MPLS in the background to route that traffic to the AP that it's seeing is the best, right? So it's creating past all of these, picking which one of those access points has the highest signal strength, and then routing the traffic that way.
So quick question there.
Sure.
So I just want to read here, this is like our
Yeah, so I think I skipped over a little bit there on that first topic. But so we have the normal Wi-Fi mode, right? But this is actually sort of the second mode that this access point supports. That's called CURB, or Cisco Ultra Reliable Wireless Backhaul. Underneath that technology, that overlay is basically MPLS kind of powering it, right? You don't necessarily directly interact with that MPLS layer. It's sort of just there working in the background. But when you're in that mode, it basically finds these kind of links and creates those paths between your access point and the wayside. So we call these the wayside because they're not moving. This was the one on the AGV. But yeah, it is a MPLS-based kind of underlay, and then CURB kind of creates the overlay where the traffic routes across the network.
To clarify, is the bottom AP actually sending packets to, so you've got AP1 and AP2 on the right there. Is it actually sending packets and then there's like some kind of deduplication process? Or is it just sending like the one series packet and then listening on the other side, or excuse me, listening and just make sure that they arrive? Or how are you switching over and over?
So this is actually duplicating the packets, right? So on this HTTP,
it is duplicating.
Yep, you have one of these. So it's duplicating those packets, right? And to answer sort of the previous question, so this was the first path, right?
Right.
Through the MPLS process, it's going to find the second best path and use that for your two packets. But here we have we call this actually the mesh end of our network. This is a device that receives both of those copies of the packets, and this is the one that's deduplicating those packets before it gets to the controller on the other side.
How does that impact it seems like an unnecessary flood of like an entire stream of traffic to me. So how do you deal with the additional congestion? Excuse me.
Sure. So when you design a network like this, right, the reason that you're doing it for something like an AGV is because you need that reliability, right? You're obviously in a spectrum wise, you're actually duplicating this traffic. So RF usage is going to double in this sense. Right. One of the kind of the benefits of the MPO feature is you don't have to select all traffic for duplication. You can actually say which QoS class, so like cost 5 or above, you could say it gets duplicated. That way for traffic that's not important, say like log messages or just messages that you're going to show on a screen for an operator that's not critical to the operation of the ride or of whatever system that you're doing, those wouldn't be duplicated. So you have some choice there. But yes, for sure, when you do duplicate this, you utilize twice the spectrum that you would have not used, without duplication.
Okay, thank you.
Sure, question.
Are you limited to only two paths? Multipath would imply more than two would also be possible?
Sure. So the technology actually supports up to 8 copies of the packets.
Wow.
This hardware today, as we're shipping it early next year, is going to support 2, but we plan to increase that in the future. I think at some point you have a return on benefit, right? Like, unless you're in an application where you could utilize probably 60 to get more of those frequencies available, you can't really do that. One thing that's kind of not really covered in this diagram is you can actually have multiple radios per vehicle, and they sort of bind together and form a virtual radio, because this radio only has 3 interfaces, so you'd only be able to have up to 3 copies, or 2 when it ships. But you could actually put 2 of these radios together on a vehicle, and then you'd have like 4 interfaces on that vehicle to choose it 4 different ways. I think for the most part, 2 is probably more than enough. We have used technologies kind of similar to this, and we've tested this technology with some customers. and they see a dramatic decrease in the amount of like latency spikes and downtime related to that when you have those two packets. And it's almost like, you know, you go from like 95% reliability to 99.5% reliability based on what they had.
So when you're talking about the MPLS part, thing comes up, sees the neighbors that are best. Environment changes, you know, somebody moves a pallet or something. Now the signal for one drops. How is it kind of constantly checking and hey, this what was my second best path is now actually my fifth best, and is it looking at the environment and kind of, you know, what's readjusting best path on a basis? Is there how's it managing that?
Sure. So when we're using the curve technology, that's pretty much continuous, right? So kind of in respect to like where Wi-Fi, even if you were using like worker bridge technology and Wi-Fi, you know, that was like pretty much a second update on when it was looking at something like signal strength. When you're using the curve technology, especially when you're using mobility like this on an AGV, it's constantly looking at the signal strength, not just for when it's about to get low, but it's actually looking at the derivative of that signal strength and saying, you know, I see we're decreasing rapidly and this other access point is increasing rapidly, right? Like if you're moving across the floor, it's going to say, you know, I should preemptively kind of switch to that new access point because it's going to become the next best. And it does that basically just changing the route path across the network rather than having to deassociate and reassociating to the new AP. So it can do that. The second situation where you're talking about if someone moved something in the way of it, like, you know, they moved, you know, maybe a forklift drove in front of another forklift or an AGV, the similar thing would happen. So you'd see that signal strength go down, or you'd see the link error rate on that other connection going down, and it would kind of move over to that second path. There is a response time for that, and I think kind of that question is kind of where we're going before, right? And especially in single path operation, that was the problem, right? Say you had, you know, something kind of come and you had no time to react to it, right? That's where you start getting that interference in your single path operation. The nice thing with multi-path operation is, yes, you have to do a little bit of kind of work on the front end saying, you know, if you have a small AGV, you need to make sure you have antennas on both sides. You need to make sure that these wayside antennas, you know, are not all, these wayside radios are not all on the same side. Maybe they need to be on multiple sides so you don't have that. But with that, with the multi-path operation, you kind of get around those issues where you see those kind of like, I call them like, you know, immediate occlusions, where, you know, you have that issue. A very similar thing happens when you're going between rooms. So things like forklifts or AGVs that are going through small areas, they have that same issue because they go from one room to another room, and, you know, you had an AP here, you had an AP here, and with Wi-Fi, they would have to roam during that time, right? And that's very minimal. So if you're building out an AGV that's going to go through doors like that, you know, that would be a good place where you could put an antenna on the front, antenna on the back, on two different channels running MPO, so that it already kind of moves to that second. When it goes to the door, it starts sending that second stream of traffic. The rear stream, you know, is going to kind of either fade away or disconnect. Then once you move into the room, it's going to pick a new one, another wayside radio, and start sending that data.
I've worked in a lot of warehouse environments, and we have that problem a lot where just that roaming disconnects. But because, hey, you moved too far away from this one, but because you were close to this one, you've already connected. You're already sending the data stream. When we drop that second one, you already have that, and you're not failing over. It's already sending the traffic. So it just rock and roll.
Yep, and that's kind of like, you know, so when you're deploying this, right, it has all those different connections to those waysides, and you kind of have to think about, you know, when the AGV in this radio kind of comes into a new area, you know, it doesn't necessarily immediately start sending traffic to the new one it sees, but it has to have a little bit of time. It's about a second to kind of make that process, right? But, you know, by having that second radio, you know, even at a very low signal strength, you know, say, you know, -85, when you're starting to come close to that door, it's already talking to these other radios, forming that path, getting ready to, when it gets close to, send that second stream of data, and then, you know, eventually kind of make that its primary path and then choose a new secondary path once it's there. And that's kind of, you know, this is kind of what that example, right? You have that interference, you drop it, you know, you drop it across the network, and you have that B. One thing I'd kind of like to mention, you know, in addition to just the wireless side of this, as it also applies to the hardware as well, right? So, you know, you have interference is kind of the what we talked about, you know, forklifts in a warehouse, for instance. But, you know, what happens if one of these radios fail, right? That's kind of the worst case on any wireless is what happens if your access point that you're connected to fails. You know, in Wi-Fi, if you fail, you basically trigger another roaming process, and you have to re-roam to one of these access points, and you have that downtime, that time where, you know, you weren't passing traffic. The same thing with MPO happens, right? So if this one were to fail, it's going to take a while for this secondary path to move over. But in the meantime, you had that secondary path available to send traffic. So to really have a hardware failure that would impact the traffic, you either have to have a failure that kind of was a common point, but you can design that out of your network, or you'd have to have two simultaneous failures, which are much less likely in an environment like this.
Is there scenarios where you have another layer of APs where you bounce to 2 radio hops to get to your big layer there? And in that case, will you have 4 that land on the...
Sure. So this is a use case where you have infrastructure to all your APs, right? So this is something like a factory, and this is kind of the main point of kind of why we developed this technology for both entertainment and a factory use case. But one of the use cases that you actually touched on is what we see more often in mining, right? So imagine open pit mining. You have dozers in the mine, and you have a data center on the outside of the mine. In that case, you can't really run fiber down to the mine because it get run over and cut. So what a lot of mines will do is they'll deploy trailers around the mine. So you'll have the same type of thing with like this being a dozer or a shovel or something inside the mine that's moving, or maybe a haul truck. We have autonomous haul trucks that are fully autonomous today. You'll have these, but rather than having these links be wired like you see here, they'll extend using that curb technology a backhaul to another radio that's on the outside of the mine, and they'll kind of push that over. And yes, you can do both, right? So if you have that second tier, you can kind of roam to that second tier. Right now, in the first iteration of this feature, we're not supporting that on those backhaul links, so those kind of fixed links. But we do plan on the future in the future to not only support that on the mobility layer here, but also have that on those backhaul links. So if you had a radio here and it was talking to 2 other radios, it would kind of cascade even a higher degree of reliability.
So you send primary, secondary, and then they send primary, secondary themselves,
yep.
right?
Yeah, and that's kind of the power of having the MPLS underlay is that it can pick the next best path, but it can also do some decision making, saying I don't want to have 2 points in that network that are the same, because now you create that single point of failure. You can kind of route that around, and sometimes it may not be the most optimal path, kind of going to the question of sometimes you put a little extra stress on your network, but at least you still have those 2 common separate paths where if you have a hardware failure or a wireless failure anywhere along that path, you're still going to get both copies of the data to the other side. And kind of to mention the same thing, these look like single point of failure, but as I mentioned, you can have actually 2 radios, and they kind of have failover between them each other. This failover on a vehicle, if one radio is to fail to the other radio, that's not instantaneous. That takes about 500 milliseconds to fail over. But what we're seeing in an AGV use case is even if it fails over, if it fails over on the AGV and then recovers, that's much better than having a human go out there and like drag the AGV back to like some place where you're going to fix a radio. Similarly here on the gateway, if this gateway or this mesh end were to fail, it would fail over in about 500 milliseconds, still able to recover your full network without having to go and actually replacing a piece of equipment. And then later you can go and replace that piece of equipment when you can schedule some downtime.
So does this work in both directions? The duplication of packets?
Yep. Yeah. So, with this, that PLC is going to do the same thing. When this gets it, it's going to send those packets the same way. So you'll get, ABC. It does work in both directions. And throughput wise, in a network, if your network gets larger, this can actually work as the mesh end and the gateway. So you don't actually have to have a separate box like shown here. But in a large network where you had a lot of AGVs, a lot of different radios going to it, we are actually developing a gateway on a UCS platform that will be able to do that and support up to about 40 gigabits per second. So in a say like a car factory where you have thousands of AGVs, they could all kind of roll up under two gateways that are redundant for each other.
You said that's being developed, as in it is not present in the portfolio?
No, correct. So right now, the curb technology exists on a previous platform that was actually acquired by Cisco from a company called Fluid Mesh. So right now we're coming out with this access point, but that access point can act as that gateway or that mesh end. It's really where you want to go past. This access point can support about 3.5 gigabits per second of throughput as a mesh end or a gateway. That's probably enough for most applications, but when you do kind of get to that large number, a lot of radios or past 3.5 gigabits per second, you'll need to go to a UCS-based controller. It's just a little bit behind this one. Right now, it's mostly supply chain and availability of UCS servers. So,
is that 3.5 gigabits duplicated in this case or unduplicated?
That's total throughput.
Okay.
So that's kind of a good design question, right? So imagine this one right here, right? You're having the incoming traffic plus you have 2 streams out. That counts against well, assuming you're duplicating all the traffic coming in, that would be like 3 times your actual base traffic. So 3.5 gigabits per second. You're looking at as long as your wireless can support a gigabit per second, and that depends on channel size, frequency, and everything. You'd be able to get about a gigabit per second throughput through that radio.
So when you do that, this is one of the fun things when people start talking about bandwidth. You're talking about basically at the ASIC level, not necessarily in a direction. So it's not like 3.5 this way and 3.5 that.
Yeah.
It can just push 3.5 gigs as a sum total wherever it's going.
Yeah. So from the CPU or the SoC on the chip in the radio, it can pass about 3.5 gigabits per second and process it at the same time. So yeah, it's total, right? I think for most use cases, when you're talking like AGVs or in a mine, you usually don't use like 80 megahertz and 160 megahertz channels. So you're probably looking at less than most cases less than 50 megabits per second. So that 3.5 gigabits per second doesn't become a factor here. It's really when you start growing the network in this box on the other side, right? If you have 1,000 AGVs all pushing 5 megabits per second, you got to account for that up here, right? And that kind of goes back to the selectivity of what traffic is important to you. Of that, 50 megabits per second on an AGV, for instance, most of that's probably going to be something like video for monitoring and not the actual control traffic. In those use cases, you're not going to duplicate the video. You're just going to duplicate that control traffic, and that's probably going to be, for most use cases, what I've seen, probably less than 500 kilobits per second. So you don't really have to worry about that until you get to a large number of AGVs or whatever you're deploying.
And when you're sending the data out, are they basically happening almost synchronously, or is there like a little bit of a delay? So if there's, hey, you just happen to drive by this, metal post, the first one hit the metal post and interference, whatever. Second one is there a little bit of a delay, or do they happen essentially instantaneously?
They're queued instantaneously, right? So kind of to your question, right? It's normal wireless, and you have that QoS of like how you put the packet on the actual medium. So there's always going to be a delay,
right? But you're not injecting a delay.
No. They're both sent simultaneously, and that's kind of when you in our testing with customers, you see that delay on the other side. So most of the time we actually just capture the Wireshark across the network because it's the easiest way for us to compare that delay. And you'll actually see that delay in that latency, right? And that's kind of how we compare and say, how much of this are we actually improving? Because, for the most part, there'll be these little latency spikes in one connection or the other, but, kind of opportunity here that most of the time, more than 99.5% of the time, either one of these will arrive with your standard latency that you're expecting. So, yeah. But where you would have that delay sending is probably where you would have had a fault or some kind of a long event where you had a long latency before, and now you reduce that because one of them did get through. Any other questions?
Are you guys looking at leveraging this multipath to look at full duplex?
That's not the intention. I mean, the intention was to solve the problem on AGVs. As I kind of mentioned, first we start with mobility, and then we're looking at kind of leveraging that for kind of the fixed infrastructure where you'd see that kind of bidirectional communication. It's not something really that we're planning to take the platform that way, right? We're not looking at becoming a full-on kind of microwave link or backhaul provider. But I think for the most part, kind of the improvements in the chipset, right? Going from, this is a 802.11 AX based chipset, it supports 6E, kind of with that extra throughput that AX brings you, it kind of becomes something that's not really needed because you can have more throughput across the link. So even in a half duplex, you gained from what you would have before. But it's definitely something I guess we could look into, but not something we're pursuing.
Underlying technology that's doing this, is this completely Cisco proprietary, or is there a kind of a possibility, that's a very large AP. Could the same technology, I mean, theoretically it could, but is there an intent to essentially make that available for putting, a wireless adapter in like a hand scanner or a laptop or whatever, other devices where I didn't necessarily want the full big AP, but I still wanted kind of that redundant wireless connection?
Sure, and the answer, the short answer to that question is not right now, but the long answer to that is really actually in the name, right? So we call this multipath operation. And in the Wi-Fi 7 standard, there's actually a feature called MultiLink Operation, which is basically that, right, for access devices. When the designers of the MPO kind of functionality in our engineering team kind of went to that, they actually kind of brought the same kind of concept back into what we have today and what we can do with Curb. And that kind of goes along the same way, right? Like today we have that need for those reliable communication in industry and industrial settings, but we're looking for the future. If you have Wi-Fi 7, you could do the same thing on a tablet and it's just built into the chipset. You know, there's a difference there that's called multi-link operation, right? That's just one link, and where this path, you can actually have multiple paths across an entire kind of topology of wireless. So the short answer is no, but it is something that you're going to see in the future with Wi-Fi 7.